In daily life, there are many situations that would require you to make alternative decisions. In a simple example, if you are in a building and you want to visit certain floor, one way to do it is by walking up the stairs or taking a lift or elevator. If you have decided to take the lift, before you go into the lift, you have to decide whether to push the up or down button depending on whether you wish to go up or down. When you are inside the lift, you have to decide what button to push depending on the floor that you want to visit. So far, all the programs that you have written could only execute a program statement in sequence. Computer programs should be smart enough to make decisions or behave differently depending on the situation. For example, when we designed the class for cars, we noticed that the move forward method would just continue to move the car even if it runs out of gas. We also failed to handle grades that are out of range when we wrote our course grade program. You should be able to fix this problem after learning the branching statements. We will discuss 3 different types of branching statements, namely the if statement, if-else statement, and switch statement. In general, all these statements consist of 2 main parts. The first is the condition part that checks if the condition, usually represented by a Boolean expression, is satisfied. The second is the action part, which performs the appropriate action when the condition is satisfied. Here is the syntax for the if statement. Notice that if is a Java reserved word. The flow of control of the if statement is illustrated in the flowchart on the right. When the if statement is entered, the condition, which is represented by Boolean expression, will be evaluated. If the condition is true, the action represented by the statement would be executed. If the condition is false, the action block is skipped. Notice that if there is only one statement in the if block, the curly bracket can be omitted. Let's now take a look at an example using the if statement. When we discussed the car example, we have used the absolute method abs in the math library to fix the problem for the move forward method when the distance is negative. We can easily write our own absolute value method. Let's call it absolute. This absolute method takes one integer argument and returns an integer, which is the absolute value of the actual argument provided as the parameter. The body of the program uses the if statement to check whether the value is less than 0. That means negative. If it is, value would be set to negative of the original value, which would make it positive. If the condition is false, that is, the original value is 0 or positive, so nothing needs to be done. The method will return value as the result at the end. The next branching statement we'll look at is the if-else statement. Here is the syntax of the if-else statement. The first part of the if block looks the same as before. Unlike the if statement, there is a second part which starts with the keyword else and follows by a block of statements. The flow of control for the if-else statement can be represented by the flowchart on the right. At the beginning of the if statement, the condition is first evaluated. If it is true, the statement within the if block is executed. Otherwise, the else block is executed, but not both. Again, the curly braces can be omitted if there is only one statement in either the if block or the else block. Let's first look at a simple example using a if-else statement, and then we'll come back with a more interesting example. This method, named larger, is supposed to find the larger of 2 integer numbers, which are provided to the method as parameters. The body of the larger method consists of just one single if-else statement. The Boolean expression checks if the first value is greater than the second value. If it is, that means value 1 is the larger of the 2, and the method simply returns value 1 as the result. Otherwise, value 2 is returned.